In biology, phylogenetics ɛfaɪloʊdʒəઃnɛtɪks is the study of the evolutionary history and relationships among individuals or groups of organisms. These relationships are discovered through phylogenetic inference methods that evaluate or observe heritable traits, such as DNA sequences and morphology under a model of evolution of these traits. The result of these analyses is a phylogeny, a diagrammatic hypothesis about the history of the evolutionary relationships of a group of organisms. The tips of a phylogenetic tree can be living organisms or fossils, and represent the end, or the present, in an evolutionary lineage. Phylogenetic analyses have become central to understanding biodiversity, evolution, ecology, and genomes. Taxonomy is the classification, identification, and naming of organisms. It is usually richly informed by phylogenetics, but remains a methodologically and logically distinct discipline. The degree to which taxonomies depend on phylogenies differs depending on the school of taxonomy. Phonetics ignores phylogeny altogether, trying to represent the similarity between organisms instead. Cladistics tries to reproduce phylogeny in its classification without loss of information. Evolutionary taxonomy tries to find a compromise between them. Construction of a phylogenetic tree. Usual methods of phylogenetic inference involve computational approaches implementing the optimality criteria and methods of parsimony, maximum likelihood, and MCAMC-based Bayesian inference. All these depend upon an implicit or explicit mathematical model describing the evolution of characters observed. Phonetics, popular in the mid-20th century but now largely obsolete, use distance matrix-based methods to construct trees based on overall similarity in morphology or other observable traits, which was often assumed to approximate phylogenetic relationships. Prior to 1990, phylogenetic inferences were generally presented as narrative scenarios. Such methods are often ambiguous and lack explicit criteria for evaluating alternative hypotheses. History. The term phylogeny derives from the German phylogeny, introduced by Haeckel in 1866, and a Darwinian approach to classification became known as the phyletic approach. Ernst Haeckel's recapitulation theory. During the late 19th century, Ernst Haeckel's recapitulation theory, or biogenetic fundamental law, was widely accepted. It was often expressed as ontogeny recapitulates phylogeny, i.e., the development of a single organism during its lifetime, from germ to adult, successively mirrors the adult stages of successive ancestors of the species to which it belongs. But this theory has long been rejected. Instead, ontogeny evolves. The phylogenetic history of a species cannot be read directly from its ontogeny, as Haeckel thought would be possible, but characters from ontogeny can be used as data for phylogenetic analyses. The more closely related two species are, the more apomorphies their embryos share. Timeline of key events. 14th century, Lex Parsimoniae, William of Ockham, English philosopher, theologian, and Franciscan monk, but the idea actually goes back to Aristotle. Precursor concept. 1763, Bayesian probability, Rev. Thomas Bayes, precursor concept. 18th century, Pierre Simon, perhaps first to use ML, precursor concept. 1809, evolutionary theory, Philosophie zoologique, Jean-Baptiste de Lamarck, precursor concept, foreshadowed in the 17th century and 18th century by Voltaire, Descartes, and Leibniz, with Leibniz even proposing evolutionary changes to account for observed gaps, suggesting that many species had become extinct, others transformed, and different species that share common traits may have at one time been a single race. Also foreshadowed by some early early Greek philosophers such as Anaximander in the 6th century BC and the atomists of the 5th century BC, who proposed rudimentary theories of evolution. 1837, Darwin's notebooks show an evolutionary tree. 1843, distinction between homology and analogy. Richard Owen, precursor concept. 1858, paleontologist Heinrich Georg Bronn published a hypothetical treatise illustrating the paleontological arrival of new, similar species following the extinction of an older species. Bronn did not propose a mechanism responsible for such phenomena. Precursor concept. 1858, elaboration of evolutionary theory. Darwin and Wallace, also in Origin of Species by Darwin the following year. Precursor concept. 1866, Ernst Haeckel first publishes his phylogeny-based evolutionary tree. Precursor concept. 1893, Dollar's law of character state irreversibility. Precursor concept. 1912, ML recommended, analyzed, and popularized by Ronald Fisher. Precursor concept. 1921, Tilliard uses term phylogenetic and distinguishes between archaic and specialized characters in his classification system. 1940, term clade coined by Lucian Cue acute NOT. 1949, jackknife resampling, Morris Guénail, precursor concept. 1950, Willy Hennig's classic formalization. 1952, William Wagner's ground plan divergence method. 1953, cladogenesis coined. 1960, cladistic coined by Kane and Harrison. 1963, first attempt to use ML for phylogenetics, Edwards and Cavalli Sforzo. 1965, Kamen-Sokal parsimony, first parsimony criterion and first computer program algorithm for cladistic analysis both by Kamen and Sokal. Character compatibility method, also called clique analysis, introduced independently by Kamen and Sokal and E.O. Wilson. 1966, English translation of Hennig, cladistics and cladogram coined. 1969, dynamic and successive weighting, James Farris. Wagner parsimony, Kludge and Farris CI. Kludge and Farris introduction of pairwise compatibility for clique analysis, Locane. 1970, Wagner parsimony generalized by Farris. 1971, Fitch parsimony, Fitch, NNI, first branch swapping search strategy, developed independently by Robinson and Moore al. Me, Kidd and Swar and Melizonta. 1972, Adams consensus, Adams. 1974, first successful application of ML to phylogenetics, Neyman. 1976, prefix system for ranks, Farris. 1977, Dollo parsimony, Farris. 1979, Nelson consensus, Nelson. Mass greatest agreement subtree, a consensus method, Gordon Bootstrap, Bradley Efron, precursor concept. 1980, PHYLIP, first software package for phylogenetic analysis, Felsenstein. 1981, majority consensus, Margush and McMorris. Strict consensus, Sokal and Rolfe, first computationally efficient ML algorithm, Felsenstein. 1982, PHYSIS, Mikovich and Farris. Branch and Band, Hendy and Penny. 1985, first cladistic analysis of eukaryotes based on combined phenotypic and genotypic evidence, Diana Lipscomb. First issue of Cladistics, first phylogenetic application of Bootstrap, Felsenstein. First phylogenetic application of jackknife, Scott Lanyon. 1986, McLeod, Madison and Madison. 1987, neighbor joining method, Saito and Net. 1988, Hennig 86, Farris. 1989 Re. RCI, Faris Her. Archie, 1990 Combinable Components Consensus, Bremer SPRTBR, Swafford and Olson, 1991 DDI, Gonabot, First Cladistic Analysis of Eukaryotes Based Only on Phenotypic Evidence, Lipscomb, 1993 Implied Weighting Golubov, 1994 Bremer Support, Bremer, 1994 Reduced Consensus, RCC for Rooted Trees, Wilkinson, 1995 Reduced Consensus RPC for Unrooted Trees, Wilkinson, 1996 First Working Methods for Bi independently developed by Li, Mao, and Ranala and Yang and all using MCMC, 1998 TNT, Golubov, Faris, and Nixon, 1999 Winklader, Nixon, 2003 Symmetrical Resampling, Golubov, Bibliography.